Welcome to aminacademy.com. In fluid mechanics, let us discuss about various losses like loss of head at entrance, exit, obstruction, bend, and various fittings in the pipe. Now let us discuss one by one. Here, first one, loss of head at entrance. Let it be this HE. This is the loss of energy which occurs when a liquid enters a pipe which is connected to a large tank or reservoir. This loss is similar to the loss of head due to sudden contraction. This loss depends on the form of entrance. For a sharp edge entrance, this loss is slightly more than a rounded or bell mounted entrance. In practice, you are taking He equal 0.5 V squared by 2G. Then we can put this one is entrance is I, you can put HI is better way. Next, second one, loss of head at exit. At exit. That means we can use it this HO. Here, this is the loss of head or energy due to the velocity of liquid at outlet of the pipe which is dissipated either in the form of a free jet, that is if outlet of the pipe is free to atmosphere, or it is loss in the tank or reservoir if the outlet of the pipe is connected to the tank or reservoir. This loss is equal to V squared by 2G. Therefore, we can write HO is V squared by 2G. V is velocity at outlet, where V equal velocity at outlet. Third one, loss of head due to obstruction. Loss of head due to obstruction in a pipe. Here, whenever there is an obstruction in a pipe, this loss of energy takes place due to reduction of the area of the cross section of the pipe at the place where obstruction is present. There is a sudden enlargement of the area of flow beyond the obstruction, due to which the loss of head takes place. Here, suppose this is a pipe. Some obstruction is take place here. This obstruction, suppose here this is V, let it be this is a section 1 and outer this is a section 2. Now let A equal cross area of obstruction, maximum cross area of obstruction, and A, capital A equal area of pipe, cross area of pipe, and V equal velocity of pipe. Now here A minus A is area of flow. area of flow in section 1. Here, because there is obstruction in the section 1, this is a area A minus A. Now, this liquid is passes through the reduced cross section. A vena contracta is formed by beyond section 1 after which the stream of liquid widens again and the velocity of flow at section 2 becomes uniform and equal to the velocity V in the pipe. This situation is similar to the flow through sudden enlargement. This is flow through sudden enlargement. That means after obstruction it flows normal depth of the normal diameter of the pipe. Therefore, we can say Vc equal velocity of liquid at vena contracta. Velocity at vena contracta. Therefore, the loss of head due to obstruction is loss of head due to the enlargement from vena contracta to the section 2. Therefore, here we can write which is V1 by, therefore velocity at vena contracta, therefore loss of head at vena contracta is Vc minus V the squared by 2G. Continuity equation, from continuity equation, AC into Vc equal A into V. Therefore, from that we can write AC is area of the cross section at vena contracta, CC is coefficient of contraction. Therefore, you can write CC, coefficient of contraction is AC over A minus A. Now, therefore, we can write, from this we can write AC equal CC into A minus A. Therefore, head loss obstruction, head loss due to obstruction you can find like that is Vc minus V the whole squared by 2G. Therefore, we can substitute Vc is A into V by Cc A minus A minus V the whole squared by 2G. So, which is further V squared by 2G A over Cc A minus A minus 1 the square. This is a head loss due to obstruction. Head loss due to obstruction, we can there's a head loss due to obstruction. We can put HO, we can put already we have introduced HO, not H obstruction. Obstruction. H loss due to obstruction. Now, here, next, Head loss due to bend in pipe. Fourth one, head loss due to bend in pipe. Head loss due to bend in pipe. When there is any bend in pipe, the velocity of flow changes, due to which the separation of the flow from the boundary and also formation of eddies takes place. Thus, the energy is loss of head in pipe due to bend is expressed as HB. You can write it's a HB equal K V square over 2G. HB is a loss of head due to bend. V equal velocity of the flow, and K is coefficient of bend. Coefficient of bend. Coefficient of bend, it is this one. Next, loss of head in various fittings. Let us give some space. Fifth one, loss of head in various pipe fittings. Now it's generally expressed kV squared by 2G, where V equal velocity of flow and K is the coefficient of pipe fitting. K equal to coefficient of various pipe fittings. We have done. Please subscribe our YouTube channel.